This video will focus on the uphole instrumentation setup, logging, and sampling procedures for the 175 groundwater profiler. This tool allows us to create an injection pressure log and also stop and collect groundwater samples in zones of high permeability. We use two 1/4-inch tubes, one to inject and one to sample, typically using a mechanical syringe pump to aid in the groundwater sampling. Connections of these tools is covered in detail in another video. The electronic actuator is another aid in the sampling process, which will work the tubing and the syringe pump to pull the groundwater sample. Setup of the actuator onto the rods and installation of the tubing is covered later in this video. Ideally, prior to logging with the groundwater profiler, you will have other HPT logs from the site that can be reviewed to determine target depths of highly permeable zones for best sample results. When logging with a groundwater profiler, we will create a new HPT style injection log. Injection rates will be in the 500 milliliter a minute range to keep the 20 screens on the probe clear. It is best to inject with deionized water so that when it comes time to take a groundwater sample, we can use specific conductance readings to determine when we are purging stabilized formation water. When we connect the groundwater profiler to the instruments, we will connect an HPT sensor uphole using a special short GWP sensor cable to the HPT controller. We will also connect a similar length 1/4-inch tube from the output port of the HPT controller to the sensor. You will want to place the water supply and bypass lines into a tank of DI water. We will now connect the injection line to the HPT sensor, which is the low-density polyethylene tube, which has been threaded through all the rods and connected to the probe. This will allow us to make an HPT pressure measurement at the surface. On the other tube that we will use to sample, we must place a plug on the end of it, similar to one we have here, which will keep water from short-circuiting up the sample line during probe advancement. As we prepare to begin our log, we will still perform an HPT reference test as always. Also, no drive cushion is required for the advancement of this tooling. The tubing and rods will be managed as usual with no special care needed for keeping the tubes separated. Ideally, we will be able to reference a previous HPT log to determine the highly permeable sampling zones, which are ideal for good flow and sampling rates with the groundwater profiler. Sampling will be done using the mechanical actuator on the rods. You should have the slotted 1.75-inch rod mount on the base of the unit. You will connect to a 12-volt power supply, and the speed of the actuator can be adjusted using the rheostat on the side of the unit. You will want to turn off the switch with the actuator at the bottom of the stroke, showing the moving arms are at their lowest position, as they are here. There is a split cap with a pair of half nylon bushings which will hold the 1/4-inch tubing in place. These are being removed from the unit, and we will take a closer look at them now. We will now mount the actuator on top of the rods. With the 1.75-inch slotted base adapter, you can bring the tubing through the slot so it does not get pinched by the actuator as it is set on top of the rods. Once we have selected the stiffer sample line, we are ready to install it in the actuator, which will also be in the bottom position of the stroke. We will remove the slotted top nut and tubing wedges. We can now place the tubing through the slotted section and replace the securing wedges around the tubing and begin to reconnect the slotted nut. Prior to securing in place, we will want to slightly pull up on the tubing, which will allow us to begin to engage the downhole pump and remove any slack in the tubing, which will provide the most efficient pumping. Before we start actuating our downhole pump, we will need to remove the plug that should be on the end of the uphole sample line to allow for sampling. We will now start the actuator on a slow speed. Once the actuator is working the tubing, and you can see there's no buildup of slack on the downstroke, which would require readjustment of the tubing and the fitting, we can increase the speed of the pumping. And now you can see that we're getting water out of the tubing. We will look at some field setup photos and data where we use the groundwater profiler. Advancement will be at a typical HPT rate of approximately 4 feet per minute, and a drive cushion is not required. When injecting deionized water into the formation, specific conductance can be monitored to evaluate when you are purging formation water in place of the injected DI water. As the tool is advanced into the unconsolidated material, an injection pressure log is generated. When you reach a targeted sampling zone, which will have a low injection pressure, an HPT dissipation test should be started in the software. The HPT pump is shut off. The actuator is placed on top of the rods as shown earlier, and the downhole mechanical syringe pump will be engaged to pump the formation water to the surface. The purged water should be monitored for specific conductance, which will be very low when purging the injected DI water, and as more formation water reaches the surface, specific conductance will rapidly rise. Once the conductance values level off, you can be assured that you are sampling formation water. When sampling is complete, restart the HPT pump and continue to run the actuator and monitor the purge water. As we inject 500 milliliters a minute into the tool and pump at 1 to 200 milliliters a minute, the DI water will replace the formation water in the sample tubing, and specific conductance will drop off to near zero. This is a system cleanup process for the probe and tubing between sample locations. Now the actuator can be removed and the log continued to the next sampling zone to repeat the process. Once the sample line is filled with DI water, we can turn off the actuator at the bottom of the stroke and remove the tubing. For the split nylon wedges, you will need a pliers to unseat and remove them. Place the pliers on the wedges and you'll rock back and forth by pulling up and it should pop out. You'll remove the tubing and replace the wedges and nut, and then be able to remove the actuator from the rods. Before you begin re-advancing the tools, you'll need to replace the plug on the end of the sample line, and then the groundwater profiler can be advanced to the next sample location to repeat the process.